How do scientists actually know the answers to really important questions? Do you think they just guess, or do they go out and collect hard evidence? Well, if you want to know how the world really works, guessing just isn't going to cut it. You need real, solid facts.
Think about it. If you wanted to figure out the absolute favorite pet in your entire school, would you just sit in your room and guess? No way! You'd go out and ask everyone, right? In today's Explainer, we're discovering how real scientists, teachers, and researchers make smart decisions using evidence instead of guesses. We're going to learn how to plan and collect data like absolute pros.
So, to do that, we use this big term, statistical investigation. Now, I know it sounds a bit complicated, but it's really just a step-by-step process that helps us make decisions based on facts rather than opinions. Whenever you're trying to solve a mystery using data, you are conducting a statistical investigation. It's a planned way to collect, study, and understand information so we can finally answer a big question. Every single great investigation follows 4 main stages. Think of this as your master flowchart. First up, you ask a question. Second, you collect your data. Third, you organize and analyze that data. And fourth, you draw conclusions. I actually like to use a fun little memory trick for this. Question, collect, organize, decide. You start with a question and you end with a decision based on real evidence.
But hold on, before you even start collecting a single piece of evidence, you have to plan out your investigation. Imagine going on a road trip without deciding where you're actually going. It wouldn't work. You need to follow 5 crucial steps to stay organized. You choose a clear question, decide what exact data you need, choose who or what you're going to study, and select your collection method, and finally, prepare a place to actually record all your answers.
It's kind of like baking a cake. Good planning is like following a really clear recipe. You have a specific question, the right group of people to ask, and perfectly organized records. Boom, your cake turns out delicious. Poor planning, on the other hand, is like baking without a recipe at all. You ask confusing questions, you talk to the wrong people, and your records are a total mess. The result? A confusing disaster that doesn't answer your question even a little bit.
So I want you to pause and think for a second. What should we investigate? What actually makes a good question? Well, it needs to be clear, specific, and easy to answer using data. Like asking, "Tell me everything about school," is a pretty terrible question because it's just way too broad. But asking, "Which fruit is the most popular in grade 4?" Now that is a perfect, specific question we can actually answer. Once we have our question nailed down, we have to choose the right kind of data. Basically, we need to decide if we're looking for categorical data or numerical data. If your question is about names or groups, like someone's favorite fruit, their eye color, or their favorite sport, you need categorical data. But if your question is all about numbers, like someone's height, age, or the temperature outside, you're going to need numerical data. Now, here's a fun little challenge for you junior detectives out there. If you decide that you need numerical data, meaning you definitely need numbers, how do you handle it? You have to ask yourself a super important question. Would you count it or would you measure it?
Here's the trick to figuring it out. If you literally count it one by one, like counting the number of students in a room or the number of books in a backpack, it's called discrete data. But if you measure it using a tool like a ruler, a clock, or a thermometer, like measuring how tall someone is or how hot it is outside, that's called continuous data. Just remember, count means discrete, measure means continuous. All right, let's dive into one of the absolute best tools a detective has for collecting information, the survey. A survey is simply a method of collecting data by asking the exact same question to a group of people and writing down their answers. It's exactly how you find out what people think, what they like, and what they do. But you've got to be careful here. A good survey question has to be completely fair. A fair question is open and simple, like, "Which pet do you prefer?" It lets the person choose entirely freely. An unfair question tries to trick or influence someone, like asking, "Everyone loves dogs, right?" That is definitely not fair. And real scientists never trick people into giving a specific answer. Let's actually conduct our very own official classroom pet survey right now. Our question is, which pet do you like the most? We have dogs, cats, fish, birds, and rabbits. Which pet do you think is going to get the most votes? Go ahead and make your guess right now before we look at the evidence. Okay, here are the raw responses we collected by asking our totally fair survey question to 5 students. Arav chose dog. Aisha chose cat. Vihan
also chose dog. Maya went with fish, and Ria chose rabbit. We wrote every single answer down super carefully on this table so we wouldn't forget anything. This right here is our collected evidence. But honestly, how do we organize that messy raw data so it's easier to read? We use a tally chart. Every time someone votes for a pet, we just draw a little line. So dogs have 3 marks, cats have 2, fish have 1, and rabbits have 1. Tally charts make it incredibly easy to count up all our totals without making any mistakes, which is a lifesaver when you're asking lots and lots of people.
And now for the grand reveal. Based on our properly collected evidence, we can finally draw a conclusion. Dogs take up the biggest piece of the chart with 3 whole votes. So, our conclusion is that dogs are the most popular pet in this survey. We didn't just guess, we found the exact truth using data.
Let's quickly summarize the core skills you need to confidently collect data and solve mysteries just like a real scientist. You always start with a clear, specific question. You plan carefully before you do anything else. You choose only the relevant data. You ask perfectly fair survey questions, and you record your data accurately so you don't mess up the results.
Let's lock this main flowchart into your memory one last time. Ask a question, collect the data, organize and analyze that data, and finally, draw your conclusions. Question, collect, organize, decide. Okay, it's time for a rapid-fire quiz to test your new detective skills. Are you ready? Question number 1. What is the very first step in a statistical investigation? Is it A, draw a conclusion, B, collect data, or C, ask a question? Think about it for a sec. If you said C, ask a question, you absolutely nailed it. Every single great investigation has to begin with a clear and specific question. Because without a question, you wouldn't even know what you're looking for in the first place.
Let's jump to the next one. Question number 2. Which tool is commonly used to count survey responses? Is it A, a stopwatch, B, a tally chart, or C, a thermometer? Think back to how we counted those pet votes.
Yep, if you said B, a tally chart, you are totally right. Now for question 3. Let's say a teacher wants to know the most popular fruit in the class. What data is absolutely needed to answer this? A, the students' heights, B, their shoe sizes, or C, their favorite fruit? The answer is C, favorite fruit, of course. You only want to collect relevant data. Okay, final challenge. True or false? A fair survey asks everyone the exact same question. What do you think? The answer is true. You literally have to ask the exact same question to keep the investigation fair and equal for everyone. You did amazing. Now, I have an exciting practical mission just for you. I want you to conduct your very own statistical investigation at home or at school today. Go ask 10 people what their favorite fruit is. Create a tally chart, just like we did for the pets. Count up the results and write down one clear conclusion based on your evidence. Go be the scientist. We've covered so much ground today in this explainer about planning and conducting surveys, but guess what? Surveys aren't the only way to collect information. Next time, we're going to unlock even more amazing methods for gathering crucial data, like interviews, observations, and real science experiments. Until then, look around you. What big mystery in your world are you going to solve with data today? Keep asking great questions.